All right, so we're going to do a few examples from the homework about Taylor series. It says in the following exercises, find the Taylor polynomials of degree 2 approximating the given function centered at the given point. So we're only going to go to the second degree. So we're going to end up, we'll need original, first, and second degree, and that's where we'll stop. So we'll be doing those things. So we're going to need to find the function evaluated at a. Then the first derivative of that function evaluated at a multiplied by x minus a and so forth. So let's try to do number 116. All right, so first of all, we need to evaluate f at a. A is 1, so f at 1 is equal to 1 plus 1 plus 1 squared. So that's 3. All right, first derivative. Derivative of 1 is 0, derivative of x is 1, derivative of x squared is plus 2x. So f prime at 1 gives us another 3, it looks like. F to the second derivative, which is all we're going with, is just 2. And obviously f double prime at 1, putting in a 1 doesn't do anything, we're still at 2. So now we need to figure out our series. So we need the second one, so P2 is equal to 3, that's our f of a, plus 3 times the quantity x minus 1, plus 2 times x minus 1 squared over 2 factorial. And I can put in the 0 factorial for the first one, the 1 factorial for the second one, but we know those are both 1. So we can evaluate this. And I guess let's do this. This gives us a 3 plus 3 times quantity x minus 1 plus, well, the 2's cancel, so it's just going to be x minus 1 squared. And that's going to be our second order for the polynomial. Let's choose a new color here. All right, in a similar fashion, we're going to evaluate this, this time at a is -1, so f at -1. It's going to be 1 minus 1 plus 1, which equals 1. Then the first derivative, that's going to be, again, 1 plus 2x. It's the same actual function that we just did in 116. F prime at -1, however, then goes to -1. And the second derivative is still 2, and obviously f prime at -1 is still 2. So we have our our first value here is 1 over 1 factorial. Excuse me, 1 over 0 factorial. Minus 1 over 1 factorial. And then we're going to multiply this by x plus 1. Remember, it's x minus 1, or x minus a, but x minus a -1 is positive. And then finally plus 2 times x plus 1 squared over 2 factorial. Let's write it a little neater here. So 1 minus x plus 1. And finally, plus the 2's cancel again. 2 factorial is just 2. X plus 1 quantity squared. All right, so let's try to do one that's a different function here. So for cosine, so our first one, we're doing it at a is pi, so f at pi is cosine of 2 pi. Well, 2 pi is the same as 0, so that's just going to equal 1. Our derivative Well, derivative of cosine of 2x is going to be negative sine of 2x, and then multiplied by the chain rule part of 2. And let's scooch over a little bit. Can. Oh, we can do that. Okay. This means that f prime at pi will equal negative 2 times sine of 2 pi. Well, sine of 2 pi or 0 is just 0, so this all goes to 0. And our second derivative, so I've got negative sine, so it's going to be negative cosine. It looks like I'm going to have 4 out there. So the second derivative at pi will just equal negative 4, because cosine at 2x is 1, and we got negative 4 times that, so it'll be negative 4. And so we should be able to finish this pretty easily. So our first value is going to be 1 over 0 factorial plus 0 over 1 factorial, and then minus 4 over 2 factorial, then times the quantity x minus pi squared. So writing this up a little cleaner, we just get a 1. The next bit is a 0, so it goes away. So minus 4 will cancel the 2 to give us a 2. X minus pi squared. And that's how you do some of those, and I'll do some more.